Peer-to-peer ride-sharing by Tim Arara. In a study made by Ning and Hanrahan, it was found that carpoolers are actively seeking cheaper, more convenient alternatives to public transit or traveling alone. They investigated groups that use online chat rooms, groups, or private messaging, and carpool apps such as Scoop, Waze, Carpool, etc. As much as Uber or Lyft advertises the benefit of flexibility, freedom, and being your own boss, research has found that drivers for ride-hailing platforms are primarily motivated to make money, while at the same time, riders primarily consider drivers to be providing them with a service. When carpooling, users use Waze, Carpool, or Scoop. That said, once they did connect with a driver, they would ask about available spots in later carpools in person. Waze allowed carpoolers some flexibility in making arrangements inside or outside the app, and reflect both types of arrangements within the app. This proved that riders eliminate the intermediary as soon as they establish a connection, which is why, according to Makridakis and Christodoulou, blockchain is an open, distributed ledger that records transactions between parties efficiently and in a verifiable and permanent manner. Blockchain provides a fundamental shift from the traditional Internet of Information and Communications to the Internet of Value, assuring the establishment of trust achieved through the application of blockchain technology between strangers. This simple but groundbreaking advantage is likely to bring disruptive changes. With trust built into the system, assets can be exchanged instantly and efficiently without the need for intermediaries. This advantage is estimated to bring more profound changes than those brought by the traditional Internet, which is why we have implemented a solution to car sharing applications, removing the intermediary and allowing users to connect instantly by using blockchain. In our blockchain application, all the code and data of the cars are distributed across the blockchain, and the code and the data is shared and unchangeable on the blockchain. To access the blockchain car list, we use a web browser to talk to the client-side application, which is written in HTML and JavaScript. The client-side application talks directly to the blockchain instead of talking to a back-to-end web server. All of the nodes on the network ensure that this data is secure and unchangeable, unlike the centralized application where the code and data can be changed at any time. All of the code on the blockchain is contained in smart contracts, which are programs that run on the blockchain. The smart contract is responsible for fetching all of the cars available from the blockchain, add new tasks, and reserve a car or ride. The smart contract is written in Solidity and the code is immutable or unchainable. For fungible tokens and non-fungible tokens, smart contracts are created using Solidity. A non-fungible token is a unique and non-interchangeable unit of data stored on a digital ledger. Non-fungible tokens and fungible tokens are built on different standards in the Ethereum ecosystem. To run the project, you must download these dependencies, which are Node Package Manager or NPM, which comes with Node.js, and it can be downloaded using the link in the presentation. You also need the Truffle framework, which offers the following functionalities: Smart Contract Management, which write smart contracts with the Solidity programming language and compile them down to bytecode that be run on the Ethereum Virtual Machine (EVM). Automated testing, write tests against your smart contracts to ensure that they behave the way you want them to. Deployment and migrations, write scripts to migrate and deploy smart contracts to any public Ethereum blockchain network. Network management, to connect to any public Ethereum blockchain network as well as any personal blockchain network, which you might use for development purposes. Development console, interact with smart contracts inside a JavaScript runtime. Script runner, which writes custom scripts that can run against a public blockchain network. Client-side development. This helps us configure your Truffle project to host client-side applications that talk to your smart contracts. To install Truffle, you can use the npm command, but you need to install this version exactly. Finally, you need MetaMask Ethereum wallet to turn our browser into a blockchain browser. This is extension from Chrome that connects to the blockchain networks, named MetaMask. MetaMask allows us to manage our personal account when we connect to the blockchain, as well as manage our other funds that we need to pay for transactions. To install, visit the link below or search for the MetaMask Chrome plugin in the Google Chrome web store.
Hello, well, we're gonna present a little bit of the hierarchy that our files have. So to begin, we have build and contracts. This one actually is divided in two. We should start with the contracts. So in here we have two .sol files, which will be our smart contracts. The only one you should pay attention to is the to-do list. As in this one, we have the smart contract uh, that is used inside our project. Uh, the build is just a JSON file which contains the same thing, but it's for Node.js to be able to read what is in to-do list.sol. After that, we have migrations, and this will migrate our to-do list.sol so we can connect it to our source and our app.js. Again, we should only be looking at the second one called deploy contracts.js. Afterwards, we have Node modules. This is actually a common thing in Node. We're not going to pay attention to that in this project.
Now, over here, we have the app.js file, which is basically the one in charge to connect our smart contracts, our account, and our wallet to the front end. Well, over here, there's a lot of code, which basically, as you can see, it has the load account code, load contract, and it also, as I said before, basically makes sure that our smart contract works properly in our front end. Now we have our index.html, which is our front end. This basically is the one that will give us the user interface. We'll show it a little bit later. But this is basically just a regular HTML page with basic HTML code. So there's nothing really to do over here. And now we'll get to the bsconfig.json and the package log.json. Both files are basically generated automatically when you create the project, because I mean, there's no way we could write like 5,000 lines of code. Then we get to the package.json. This is a really important package because it is the one that defines which version of codes and dependencies are we using. For example, we have Bootstrap 4.1.3 and Truffle 5.0.2. And this is very important because if you don't run the program in this Truffle version, it will not work, as my partner Giselle said before in the presentation. So it's very important to not mess with this file, because if you do, the program will not work. And finally, we have the truffle.config, which is the one that will decide the host and the port of our truffle. And also we have the network ID, which will help us with our wallet and will help us to match any network ID. This is in order to simplify the explanation and the tests, because if we didn't do this, we would have to define an ID and make sure that it works every single time. So it is better to do it like this. And this is basically our structure, our code structure. And now we'll show you how our program works.
Okay, so now we're gonna run our project as my friend and Giselle said, we're gonna need a Ganache project to be open before we run our application. It's very important to say that we did not use a quick start. Rather, we created a project, as if we made a quick start, then there would be a couple of issues when trying to address our first, well, address. So we're gonna open a terminal. Okay, so something very important, if you're gonna run our project once you have it downloaded, is to write npmi or npmi install. Well, the I is short for install. This will install all of our dependencies on your computer. Okay, now what you're gonna want is to do a truffle migrate reset. So this will clean our wallet, so our project can work properly. So let me just clean it. Okay, so no issues. Now we can begin. We're gonna want to do a npm run dev start. This will actually initialize our application. And as you can see, our app has opened. Now, what we're gonna do is, and as my classmate Giselle said at the beginning of the video, you're gonna want to have MetaMask, which is a Google plugin. This will work as our wallet, and it's totally free. You can find it in the Google store, well, in the Google plugin store. Well, let me just enter. It's very important for us to be running it on a local host. You can select that in the networking tab. You will also want to have an account. So how do we get an account? We're gonna go into this little circle right here. And as you can see, we already have a couple of accounts ready. We'll be working with account number 5, but you are gonna need to import an account. So we're gonna go and import an account, and we're gonna want, well, here it's called clave privada, which is basically this key in Ganache. It's our private key. We're gonna need to copy this and paste it in MetaMask. Now let's try to, well, as you can see, we have 100 ether. Let's try to etheride. So let me write down, just as an example, ride.
As you can see, now we have 0 ether, which is a problem we ran into. And this is mainly because somehow the program doesn't recognize the transaction, and it says that we have no gas. As you can see up there, it says estimated gas fee and all values are 0. So basically, this shouldn't be like this, but if it worked properly, we should be able to click in the confirmar button, which is the one blue shaded at the bottom, and we should be able to see now the task added in our user interface. But this is a problem we can solve somehow. If you can open the terminal and see the problem, it says something about this specific error, which is basically there is no gas. So this is our main issue, but this is basically what prevents us to complete our project. Because apart from this, everything else works properly. We have our user interface, and we are able to create transactions, but not to execute these transactions. And this is basically it.